Yeah, welcome back everybody. We're taking more questions on bearings and distances. But before we go, let's go over this very quickly. Okay, the last one we took was number 8, so we're starting from number 9. Let's go over this very quickly. If this is a point P, for example, let's say this is point P and this is another point Q. This is another point Q. If I join P to Q this way, this is point Q. The bearing of Q from P is the angle from the north pole at P to the line that joins P to Q, this angle, while the bearing of P from Q in the same fashion is the angle from the north pole at Q to the line that joins Q to P. That's the bearing of P from Q. This is the bearing of Q from P, and this is the bearing of P from Q. That's it. That's very important in solving questions on bearing. So let's now go to the question number 9. It says a boat sails 4 kilometers on the bearing of 038 degrees and then 5 kilometers on the bearing of 067 degrees. Question A, how far is the boat from its starting point? Question B, calculate the bearing of the boat from its starting point. That's an easy one. Let's go straight to it. Let this be the starting point of the boat. Let me call it point P. Now, it sails 4 kilometers on the bearing of 038 degrees. 38 degrees, you read it from the north, don't forget. 4 kilometers. Let me make that 4 kilometers. And then this is 38 degrees. Now, from this point, it then moves on a bearing of 5 kilometers. It then moves on a bearing of 67 degrees, another distance 5 kilometers. So if this is where it is now, this is where it is now, and it's moving on a bearing of 067 degrees, another distance 5 kilometers away. So that's the bearing. Let's call that 67 degrees. And the distance he moved was 5 kilometers from that point. Now this is where the boat is. This is where the boat is now. Let's call this point where it is R, and then this one Q. So it started from point P, moved to point Q, and then from point Q to point R. So the first question says, it's actually question 9A. First question says, find the distance of the boat from its starting point. So we're finding the distance PR. That's what we're finding. Distance PR, simply. Maybe I should reduce this a little. The length of that a little, yeah. So if this is 67 degrees, that simply means this is going to be 23 degrees. 90 minus 67 degrees. And if this is 38 degrees, this will also be 38 degrees. Alternate angles. And I know that this is 90 degrees. This is 90 degrees. Which simply means the whole of this angle is 23 plus 90 plus 38 degrees. Just to make my diagram a little neater, let me label 28 and 38 degrees outside the diagram. This is 23 degrees and 38 degrees rather outside. This is also 38 degrees. So the whole of this is 38 plus 90 plus 23 degrees, and that's 151 degrees. So now how do we find distance PR? That's very simple. Let me just call this x. Using the cosine rule, x squared is equal to, oh, I didn't label, the distance from P to Q is 4 kilometers. It sails on a bearing, it sails 4 kilometers on a bearing of 038 degrees. So distance PQ is 4 kilometers, and then 5 kilometers on a bearing of 67 degrees. That means QR is 5 kilometers on a bearing of 67 degrees. So that's here the diagram simply. X squared will now be 4 squared, x squared equals 4 squared plus 5 squared minus 2 times 4 times 5 cos 151 degrees. Remember the cosine rule. That's how to apply it. Now that simply means x squared equals, let's check that, 4 squared plus 5 squared minus 2 times 4 times 5 times cos 151 degrees. That's equal to 75.9848. So x is therefore the square root of that, 75.9848. Square root of that answer, let's check that, and that's 8.717. And they said we should approximate all distances correct to three significant figures and bearings correct to 0.1 degree. So this is approximately 8.72 kilometers. Therefore, the distance of the boat from its starting point is 8.72 kilometers. Now, question B. Let me copy the diagram and paste it to answer question B. Now, this is the diagram. Yeah, just to answer question B. That's the diagram. Question B says, calculate the bearing of the boat from its starting point. That simply means we are finding this angle. The angle from the North Pole at P to the line that joins P to R. That's the bearing of the boat from its starting point. And since I already know this to be 38 degrees, then I can just find this, let me call it theta, and add it to 38 degrees. That's the bearing of the boat from its starting point. So now I want to find theta. How do I find theta? Sine, I can use sine rule simply. The angle facing theta, the length of the side facing theta, which is 5, all over the sine of angle theta, will also be equal to another length that we know divided by the sine of the angle facing that length. So I'm saying 5, I'm doing 5 over sine theta equals x over sine 51 degrees, because I already know x. So the only unknown in that equation will be theta, and I'll be able to find it. So let's go. 5 over sine theta equals x over sine 151 degrees, which simply means 5 over sine theta equals x is 8.72 kilometers all over sine 151 degrees. So if I cross multiply, sine theta is going to be equal to 5 sine. If I cross multiply this way and make sine theta the subject, I'm going to get 5 times sine 151 degrees over 8.72. Sine theta will be 5 sine 151 degrees over 8.72. So let's do that. 5 times sine 151 degrees divided by 8.72, and that's 0.27798. let's say 2780. So theta is therefore the sine inverse of 0.2727, the sine inverse of 2780, or simply 278, which is equal to sine inverse of answer, and that's equal to 16.14 degrees. So therefore the bearing of the boat from its starting point, which is 38, the whole of this, to the whole of this, 38 plus theta, is now going to be 38 plus 16.14 degrees, and that's simply 38 plus 16.14, and that's simply 54.14 degrees. And they said we should approximate angles correct to 0.1 degrees. That's simply 54.1 degrees. So the bearing of the boat from its starting point is 54.1 degrees. That was a very simple one. Now let's go to the next, which is number 10. Number 10, what does that say? A photographer is 350 meters away from a lion and wants to get closer before he takes a photograph. There is a water hole in the direct line between the lion and himself, so he moves at an angle of 8 degrees to this line to a better position. 200 meters further on. Calculate his distance from a lion. Okay, I think that's supposed to be easy. Let me assume this is where the photographer is. That's number 10. If the photographer is here and the lion is here, then the distance between them is 350 meters, and he wants to move closer to the lion, which made him move at an angle of 8 degrees to the water hole in the direct line between himself and the lion. So that means his own movement will be in this direction, let's say, and that movement is 8 degrees at an angle of 8 degrees to the distance between the photographer and the lion. Now they're asking for the distance between the photographer and the lion, which is this point, this line, the distance between where the photographer is now and the lion. This is just a sketch, by the way. Let me make this a little longer, and then join this way. So this is where, let me call this point A. Point A is the starting point, B is where the photographer is now, and C is where the lion is. So the distance he moved to be at an angle 8 degrees was 200 meters. So AB will be 200 meters. Now we're finding distance BC. Let me call that Y. So using cosine rule, Y squared will be equal to 200 squared plus 350 squared minus 2 times 200 times 350 multiplied by cos, I need to move that back a little, multiplied by, I want everything to be on this on a single line, multiplied by cos 8 degrees. So that's it. Let's check. 200 squared plus 350 squared minus 2 times 200 times 350 times cos 8, and that's 23,862.47, yeah, approximately. So y is going to be the square root of that, 23,862.47. Square root of that answer, square root of the answer is 154.475, and they said length should be given correct to 3 significant figures, and that's simply 154 meters. So that answers that very, very simply. Now I think we should pause there and then continue and come back in a bit. So let's see.